Welcome to our webinar, How to Run ANSYS Faster with Rescale. I'm Mika, Product Marketing Manager at Rescale, and today presenting is Fanny, our Director of Solutions at Rescale, and Roswell, an Applications Engineer. From ANSYS, we're also joined by Wim, who's the Marketing Director for HPC and Cloud. I'd like to go over a couple of housekeeping items before we get started. First off, we're recording this, and I will be distributing the recording later this week, as well as in our March newsletter. And secondly, if you have any questions during the webinar, please make sure to enter them, type them into the questions section in the GoToWebinar panel, and we will address those in a Q&A session at the end of the webinar. Okay, Fanny, go ahead.
Thank you, Mika. And thanks. I would like to thank Wim for joining us today as well. So today I would like to show you how to run an ANSYS product on Rescale. So ANSYS has this vision called Digital Twin. So they want their customer to be able to really put simulation in the heart of the development process and have simulation driving the design process rather than coming at the end for like simply the validation. So if we look at the graph here, simulation should be helping driving requirement definition. Simulation should help integrate the different systems together and assess the risk across the stack. You should be able to do more upfront analysis with ANSYS AIM. You should be able to also leverage simulation, of course, for the verification and validation process to reduce the number of prototypes by leveraging all the different ANSYS products as well. And really, you come to realize this digital twin vision by being able to leveraging ANSYS CADE and their new partnership with GE Predicts and ThingsWorks to be able to connect the data coming from the actual physical product and your actual prototype or testing mechanism, and link that back to your simulation model, so you actually are able to predict how your design is behaving and predict if it's going to fail, and always refine your simulation model so you can look back and be more accurate when you go and design that product. So to be able to realize that vision, we think that at Rescale, you're going to need to transform your IT environment, and we think that the cloud is the best solution for that. So first of all, to be able to rely more on simulation, you're going to need to increase the confidence in the results. So for that, you're going to need to have a bigger model, refined mesh, more physics, and you're going to need the compute power to be able to solve those large problems. So the cloud, of course, is the best environment for that, giving you massive compute capacity. Then you're going to need to accelerate simulation throughput and do simulation at every stage of the design process. So in the same way, the cloud and Rescale allow you to be able to assess tons of different configurations at the same time, and therefore accelerate the number of run and configuration that you're testing. And finally, to be able to realize this digital twin vision, it's going to be important to break the silos within the organization. And the cloud is a perfect fit with Rescale to be able to allow you to collaborate, to be able to share data easily between groups and colleagues. So today, what I'd like to show you is how, using Rescale, you're able to leverage ANSYS product to run larger model and accelerate simulation throughput while allowing you to collaborate with your coworker. So first of all, at Rescale, we bring all the different ANSYS products and all the different physics that you're going to need to model this digital twin. We'll bring that together into the same platform. So you always have available at your fingertips the different physics, but also all the different release of ANSYS to you. So when a new release comes, you don't need to spend any money into services to make sure that this new version is enabled in your system. We also have an interface to allow you to manage the different type of license. Either you're using HPC pack, HPC parametric pack, elastic licenses. If it's either on your premise or on the cloud, we'll allow you that. We're flexible in allowing you to manage those licenses across the different needs. We are also providing a tailored workflow interface to allow you to migrate those complex simulation workflows into the cloud. And finally, we also provide a support interface, so you can interact directly with a support engineer to get the help you need to make your simulation work on the cloud. So essentially what we do is we take this really complex on-premise stack with a lot of different software and a lot of different middleware and tools and compress that and make it available as a turnkey platform on the cloud. So now you can access all of your simulation and the ANSYS product from a web browser and a SaaS interface. So at Rescale really provides two interfaces that you can see here on the screen, and we provide different components as part of our SaaS interface. So as I mentioned, we support all the different ANSYS products, but we have more than 180 software available to you. Our platform is built on a multi-cloud infrastructure, so you can leverage the different cloud infrastructure to make sure that you're using the best hardware at any time. But you can also we can also connect with your on-premise HPC to enable a hybrid kind of system to allow you to easily burst to the cloud from your premise. As I mentioned, we have a workflow tools that allow you to not only just submit a job to the cloud, but also bring with you your post-processing script, define different parameters to automate some of those repetitive tasks. We also have an administration interface that allows you to monitor the usage, your usage on the cloud, be able to also define different hardware or software restriction, and set all the different security settings that you need. And finally, our platform is secured. The data are encrypted while at rest and in transfer. We also provide multi-facet authentication for user login. And you can also restrict the different IP range as needed. So our platform is a global platform. We have more than 57 data centers at 28 locations. We support both virtual machine, but also bare metal. And as I mentioned, we're built on a different services, including Amazon AWS, Microsoft Azure, SoftLayer, Google Cloud, but also some private data centers like OSC that I haven't listed here. And as I mentioned before, our platform is secured, and we have different certifications like SOC 2, ISO 27001, and also for some of you that needs to work in an ITAR environment, you're also with Rescale able to run your simulation safely on ITAR. So as I mentioned, our platform is a multi-cloud platform. And why is that? So what we've noticed across different years is the hardware is getting more and more specialized. The time where you were running on just CPUs is over. So with Rescale, you're able to leverage different type of processors now that's going to give you much better performance. So you're going from being able to use CPUs to now be able to leverage also coprocessor, GPUs, FPGA, or even if you're running more like deep learning type of analysis, Google has its own specific hardware to run a TensorFlow called TPU. And we see the same trend with the interconnect technology, with InfiniBand, NVLink, etc. So by leveraging the cloud, you're able to leverage the most specialized hardware, but also the newest one. So what you see here on the right is a benchmark from one of our customers that were using quite old HPC hardware in his Promise. And by running that same simulation on the cloud, you can see that we were able to cut the time by 10 on that CFX, ANSYS CFX analysis. And of course, as you start throwing more cores into that simulation, if given that your model is scaling, you're also able to reduce time considerably. Same is true here as another example. When you use ANSYS HFSS, you might want some memory intensive core that you can leverage through the Rescale HPC network. And as you can see here on this graph, is depending of the different type of hardware that you're going to use, you're going to have different performance. And you're going to also save considerably amount of time by leveraging more cores. What's interesting is if you look at the HPC pack, the ANSYS HPC pack licensing model, is as you use more core, essentially the price of the license is actually getting cheaper. So if you, for example, run an analysis on 128 core, it's going to cost you basically the same to run on 512 cores. So it's very beneficial for you to, in terms of license, to actually leverage more core when you can with the same amount of HPC pack. And same is true if you look at GPUs. ANSYS really favored the usage of GPUs through their license model. So one GPU is really treated the same way than one core. And here, if you look at this benchmarking model, you can see that the performance that you gain by using GPUs, and here in this benchmark, we're looking at the Tesla K80 technology from NVIDIA. Again, you can see that you have up to 3.2 performance improvement on this landing gear, for example. And now if you're actually looking at the different license counts, you can see that for about the same amount of license, you really are able to cut the time tremendously and get results a lot faster, which is so important for this digital twin vision. So now that I've talked a little bit about the HPC pack and HPC parametric, I'd like to give the hand to Wim to talk about the elastic licensing model.
Yeah, thank you, Fanny, and for giving me the opportunity to present indeed a few slides on licensing. And because licensing is usually linked to specific usage scenarios, I have categorized them basically in three major groups. And the first one is shown on this slide. And although I may oversimplify it a bit, I hope that you will get the underlying message that three primary customer cloud scenarios, each with its own business and IT driver, requiring really specific licensing model. And as you can see, again, the first one is tied to the growing need for scaling up HPC resources to support bigger and more demanding engineering simulation workload. And because some customers may lack internal IT support expertise, they're interested clearly in HPC outsourcing through some kind of virtual private cloud solution. And clearly, at the same time, they want to enable also collaboration, and their cloud comes into play, as Fanny already alluded to, with multiple data centers around the globe. So because of its so-called steady workflow, nature, here the traditional lease and perpetual licensing model is applicable. Then as a second cloud scenario, that one is really related to the need for more HPC resources in order to deal with what I call urgent or unexpected or unplanned projects that can, for example, arise in response to process equipment shutdown or product failure or whatever. We see here the internal HPC for steady workflow combined then with the burst capacity needs for project peaks, and this type of hybrid model would require more HPC capacity for short term, and therefore the short-term lease and licensing model is applicable and likely most cost attractive. The third one, actually, the third, let's say, cloud scenario is related to optimizing hardware and software utilization, where customers have an intermittent need for HPC resources that exceed their owned assets, so to say. And here the elastic HPC cloud scenario is really a way to optimize spend and asset utilization rates. And for that matter, the usage-based licensing model is most suited and has been introduced by ANSYS in last year, actually, in 2016. And before, let's say, explaining our usage-based licensing model, let me just quickly say that that all of these scenarios, the above scenarios here, can be deployed at Rescale Cloud, and not only in terms of hardware, but also in terms of software deployment. So next slide. So on this slide, I want to explain our usage-based license model, which is called ANSYS Elastic Licensing. This is a pay-per-use licensing model that enables usage-based licensing of virtually every ANSYS product, and it is accommodated through a single license product called ANSYS Elastic Units. So essentially, you will buy a number of elastic units, and from this pool, each ANSYS product consumes a number of these elastic units per hour, or any fraction of an hour, down to a minute, and you pay per minute then. So similar to buying, let's say, a coffee cart from Starbucks, where you also invest up front in a defined amount of elastic access. This is very similar, but now with ANSYS software. So in essence, it helps you to meet your peak capacity demands, and also, as mentioned, it allows you to pay only for what you use, similarly to cloud computing resources. And it's very important also that it provides you the ability to allocate license costs. You will actually get a dashboard and see where your licenses are being used, how many licenses are being used, etc. And if needed, this is also a way to bill certain license costs back to a business unit consuming these products. And although we've initially released elastic licensing for cloud deployments only, we are now also about to release it for on-premise usage, so that you will have the full flexibility, whatever your preferred hardware deployment model is and looks like. So I can tell that you can use elastic licensing from wherever, from anywhere in the world where you are, and have access to Rescale Cloud, and wherever your ANSYS users are located. So I'm obviously very glad that Rescale can offer you the entire mix of ANSYS licensing model. And thank you, Fanny, for giving me the opportunity to elaborate on that.
No problem. Thanks, Wim, for those details. So now we've seen that using the cloud, you're able to take advantage of the different license model that ANSYS provides, and essentially reduce the cost of your job by leveraging more cores. But now that you have those massive kind of large model that you want to run, those large digital prototypes, you need a way to make that as efficient as possible on the cloud. So Rescale does provide a end-to-end solution for you. The advantage of the cloud here is you're going to generate those large result files or large mesh files right next to your HPC, and you'll be able to store them, to manage them, and to process them using Rescale without having to move those files. The other benefits of the cloud here is you have now all your simulation files into one centralized location, and you can easily share those files with your coworker without having to move them around. Of course, if you need to still work out of your on-premise environment and maybe, let's say, pre-process your ANSYS Job using your local machine, you're also able to leverage Rescale multi-threaded capabilities or other capabilities of Rescale to automatically upload and download files back from your premise to the cloud and vice versa. We also allow, as mentioned earlier, integration with your scheduler to be able to seamlessly burst to the cloud. So enough with the slides. Now it's time for a demo. So we'd like to show you how we're going to handle your simulation workflow on the cloud end-to-end. So I'm gonna pass the hand to Raul now for a live demonstration.
All right, thank you, Fanny. So let's get right to it. So what you see here is actually the Rescale platform, and it's just it's live on the browser, and we'll start by setting up a new job. So this can be found in the panel on the top left-hand side. Okay, new job, and the first thing you want to do is to name your job so that you can keep track of it. So let's just go ahead and call this ANSYS Webinar. And as Fanny has mentioned before, we have an end-to-end solution, and this, you can see that the workflow for the setup of a job on the right side. And basically what you have to do is supply your input files, set up your configurations for software and hardware, and you are ready to submit your job. So for input files, you have two options. First, you can upload it directly from your computer using our multi-threaded transfer, or you can upload it directly from cloud storage on Rescale. So for today, let's go straight into cloud storage. And what we need for today is would be, let's see, the T-junction input file as well as the journal file. And you can see that you are able to edit the files directly on the browser in case you want to make a few changes as we go along. So next, we would like to set up our software. And this is our software settings, and mentioned we have a wide range of software, and let's go ahead and search for ANSYS. All the ANSYS products can be found here, and for today we'll be using ANSYS Fluent. So we support a wide range of versions of ANSYS, and today we'll be using 17.2. And over here you can see the command box to supply the shell command to run ANSYS. And for those of you who are not too familiar on shell commands, not to worry. Rescale has a few command templates for you to easily use, and all you have to do is just replace the placeholder over here with the journal file name for today and make any necessary edits onto the command. As for licenses, it was also mentioned that you can use your HPC pack license, which is using your existing license. You just have to enter details inside here. Or you can use the on-demand license provided by Rescale, which was the Elastic licenses that Wim was talking about. So now that we are done with our software settings, we can move on to our hardware settings. And over here you can see all the hardware that Rescale provides. We have a wide variety of hardware. We have hardware on the virtual machine, we have hardware on bare metals, and We also have GPUs such as Obsidian over here. And those of you who need more specialized hardware, we actually have some specialty cores. Basically, you have a larger selection of higher memory cores as well as different types of interconnect. And it's as simple as choosing the number of cores you want over here. And you can also set a maximum overclock time just in case. So in the interest of time today, we're going to use one of the clusters that already started beforehand over here. And next, there's actually an optional post-processing step, but we're going to skip that for now. I'll demo it later on. And what you want to do right now is head over to the review page, make sure your configurations and settings, everything is ready, and once you're ready, you can click submit. So what's happening right now is Rescale's uploading all your files and sending it to the cluster. And over here, you can see the live tailing window. And what this allows you to do is basically see your files modifying along the way. And this is the process output.log. And basically, this is the terminal or the bash output for your job. And you can see that the iterations are running right now. Yep, you can see it updating live. And if you'd like to do to actually access your cluster, we have in-browser SSH enabled, and you just need to click over here, and there you go. You have a terminal window for you to play around with. All right, so now the job is running. We also have the capability to visualize your jobs on the cluster. And you can actually do that using the visualize button over here. Once you hit it, you're sent to a remote desktop, and you can visualize your simulation over there. So I've already started up. All right, just before I forget, we actually set up this job to output files, a graph along the way. So as you can see, the graph is currently at around 100 iterations, and if you refresh it and look at it again, you can see that the iterations have progressed, and this way you can monitor your job live without having to SSH in or go through any special measures. So for post-processing again, let's head over to the desktops tab over here. I currently have a desktop running, and it's very easy to set up. You can just need to choose the configurations. We have Windows desktops and Linux desktops. All you have to do is add software. So for today, I've added ANSYS structures and attached the jobs that you would like to visualize. And once you're done, you can actually launch your cluster. In this case, it's already launched, and you can directly connect to it. So now you have two options to connect to your remote desktop. You can either use the RDP client, or with one of our latest releases, you can actually use our in-browser desktops, and this would allow you to use your desktop right out of your browser. And let's go ahead and do that. So as you can see, I'm still within my browser, and I have my desktop booted up. This is a visualization of the T-junction model that we just ran, and this is the Fluent client that you see over here, and you can do whatever you need to, either to pre-process or to, in this case, post-process your job. So for some of you who are not too familiar with the batch environment, you can also use Workbench. It's supported on our remote desktops. And once you launch Workbench, you can see your typical workflow or your setup for your jobs. And what you can actually do is to use Rescale to power your simulations by using the Remote Solve Manager. You can set up your entire workflow and the job on the cloud or on our remote desktops, and get the simulation to run on our Remote Solve Manager on Rescale. Sorry. So let's go ahead and give you a demo of that. So I've loaded up a very simple model on ANSYS Mechanical. So all you have to do is enter the properties menu over here, and you can see the solution process option. Just need to change it from run in foreground to submit to Remote Solve Manager. And over here, you can see you can change and choose from various core types in Rescale. And today we'll be using Onyx, and change it to a parallel execution mode with 4 cores. And once you're ready, you can actually hit update, and you can see that the job will be submitted directly onto the Rescale platform. This typically takes about a minute or so, and in the meantime, let me take you back to Rescale and go through some of the features in the Rescale platform. So as mentioned by Fanny just now, all of your files as well as your jobs will be hosted into one location in the cloud. And this is the dashboard right here. You can see all the jobs that I've previously run. And you also have the ability to share the jobs with your coworkers. As you can see, I've shared some of these jobs with my coworkers over here. And my coworker Hiraku has shared a job with me recently. And this can be done by going to any of the jobs and hitting the share button. And you can enter your coworker's email over there, and the job will appear in their dashboard. At the same time, you can also share the job with Rescale support. This way, we can have access to your jobs and help you troubleshoot or take a look at anything you want us to. If there's any other need to further contact us, you can also hit the chat window over here. And right now, you can chat directly with one of our engineers during office hours to make sure that your job is set up correctly or to provide any other form of technical support. Okay, awesome. As you can see, the RSM job that we just submitted has appeared in our dashboard, and it's currently being validated, and the cluster is starting for solve. So I'd like to pass the time back to Fanny to continue on a new feature on Rescale.
We can stay here. Yeah. All right. Thanks a lot, Raul. So through this demonstration, we saw that you're able to submit. This was for demo purposes a pretty small model, but you can do that with a very large model as well without having to move the data around. You can pre-process, post-process everything on the cloud. You can also monitor your result while it's running, either like interactively using our desktop capabilities, or from the Rescale SAS interface with the live tailing, or by outputting some result plots. And as Raul showed, you can also share your job to allow collaboration with coworker. So this is a great demo to show how we can scale like very large model on the cloud, but one of the benefits of the cloud is the ability to leverage the compute power to run very large DOE. And again, ANSYS provide a special licensing system called HPC Parametric Pack that's going to allow you to take advantage of the cloud to run a larger DOE. So as you can see here on the graph, the more the more design points you're going to explore, basically the cheaper your HPC Parametric Pack's gonna cost per run, really. So what is the advantage of using the Rescale DOE framework? So typically in your on-premise environment, you're going to have your different jobs. So here I have 4 jobs represented by a cube. So you're going to have all those different jobs queued. And basically the time to get your result back is going to be pretty long. So you're now using the Rescale DOE framework, you're able to concurrently run multiple jobs at the same time using the number of core per slot here. So you can, so now basically instead of queuing your job, you can run all of them together and cutting the time by 4 in this example. And of course, not only you can run those jobs concurrently, but you can also throw more cores at your analysis to reduce the actual turnaround time of a single job. So essentially now with the cloud and with Rescale, you're able to, 1, use more cores, 2, run jobs concurrently, so you're able to really cut the time from like those 4 jobs pile up to like a stricter minimum right there, as shown here. So now what we would like to do is walk you through another demonstration of the Rescale DOE framework. Raul is going to use the same model. He's going to vary different input parameters and to be able to output the different temperature for a given parameters. So Raul, back to you.
Okay, so for the DOE, we're just going to clone a job that we previously ran. And you can see that I set up a job yesterday. And by hitting the clone button, you are able to clone all the settings as well as the input files and everything that you set up in case you'd like to make a small change or run the model again. So as you can see, the framework over here is slightly more elaborate because you're able to provide more options and different configurations. So this is currently the DOE job type on Rescale. So what we have over here, we're currently in the input step. We have the input file defined just like just now. And next we have this new step called parallel settings. And this is where you actually specify your variables. And for today, we have actually specified two variables, which is the temperature of the inlet, the hot water inlet, and the temperature of the cold water inlet. You can see we have set a minimum value and a maximum value with increments of 10. So this gives you 6 different configurations, but we're also running a cross product of all the different permutations available. Or you could also upload or use your own CSV file as a parallel setting. Next, we can go on to the templates. What a template is basically the file that the Rescale backend would replace the variables in. And in this case, we're actually with a very simple journal file over here, and you can see that there's a variable defined that has to be replaced. So whatever we defined previously will be replaced in this template for each run, and that would vary the input parameters. So now we have done that, we can go straight forward to something more familiar, which is the software configurations and the license options and the hardware settings. So I just want to make sure I have everything set up here correctly. And for today, we have also set up a post-processing script. It's a very simple shell script. What it does is just to pass out the output temperature for us to view later on. So now that everything is set up, okay, sorry, you need to also have a post-processing command afterwards that will be run after the simulation is complete. So let's head over to review, make sure that all the settings is set up correctly, and once we are sure of that, all you have to do is just hit submit, and the job will be submitted to the Rescale platform, similar to just now. So in the interest of time, I already ran the job before this, and this is what the results page, which can be found over here, would look like for the DOE we just ran. So with the different configurations, you can see that we have 16 separate runs that were done. You can see the duration for each run, and you can see the input parameters over here and over here. And thanks to the post-processing script, we were able to pass out the results, which can be displayed here. So just in one dashboard, you can see an overview of all your runs and second half. Also on Rescale, we have a charting ability, so we can take all this data across runs and actually chart them. So what we have done here is to chart cold temperature and hot temperatures against the outlet temperature. And this is a very useful tool to ensure that you can go through all this right here from your web browser anywhere on the Rescale platform. So with that, it's the end of the DOE demo. I'd like to pass my time back to Fanny. Oops.
Thank you, Raul. Great demonstration. So in this demonstration, you were able to see how to leverage the DOE framework to run a lot of different configuration of a job simultaneously at the same time. And you also saw how we can automate some of the tasks using a post-processing script and extract some of those key value and display it in one single table, so you can see and review your results in one single place. We've also seen the chart capabilities that allows you to compare the different configuration and be able to make a better design decision essentially. So just to conclude, you've seen through this webinar that thanks to Rescale, you're able to really tailor your cloud simulation to specific application. So let's say, for example, you have a 2 million degree of freedom nonlinear stress analysis. You're able to pick the right application through Rescale to tackle that engineering problem. So let's say here you can use ANSYS Mechanical. And maybe you're working for a specific project that happens only once a year, or maybe this is more a R&D project that you're not used to really run and don't specifically have the compute capacity for that. So you can leverage the ANSYS Elastic Units to be able to burst that simulation to the cloud using more compute power. You'll be able to run on this application on multiple core, and maybe specifically for this application, leverage GPU accelerated nodes to get better performance. Now, if you are running, if you have a more routine analysis, let's say EMAG frequency sweep analysis, you are able to run it using HFSS, the ANSYS product for electromagnetic simulation. And here you'd like to run a DOE analysis around the different frequencies. So you can use the DOE framework to keep the cost of your job lower. So you'll be able to run it on multiple core, but also on multiple slots at the same time to run different configuration concurrently. And because you're using HFSS, you might want to use a high memory node for that specific application. And finally, if you are running Fluent and a large model, a large CFD model, you can access Fluent. You're able to not only solve your job on the cloud, but you can also generate your mesh on Rescale from the pre-processing interface or in batch using a high memory nodes and multiple core. And you can also then, after that, solve your analysis running a large number of core and something like leveraging the InfiniBand network. So in summary, you've seen through the different demonstration and different slides that you are able to accelerate the design exploration, the technology exploration, and the innovation using Rescale and the DOE framework by assessing tons of different design at the same time. You're able to automate some of the ANSYS standard processes by bringing your script in, extracting key value data, etc. You're able to run your job sequentially or concurrently, and by that you are really able to reduce time drastically as well. And finally, by combining the different type of ANSYS license, HPC pack, HPC parametric pack, and the ANSYS Elastic license units, you're able to bring the cost down, optimize for better kind of license efficiency use on the cloud, and you're able to use the latest and most specialized hardware available for that specific application.
Okay, thank you, Fanny. That wraps up the presentation portion of our webinar. We're going to move on to Q&A next. So if you haven't already done so, now is the time to type in your questions into the questions section on the GoToWebinar panel. While you do that, I just want to point out that as a thank you for attending today's webinar, all attendees will receive a $20 Rescale credit that's valid for hardware usage on the Rescale platform. You'll receive that promo code in a follow-up email from me sometime later this week. And you can sign up for an account at www.rescale.com/signup. Under account settings, you'll see a promotional code field at the bottom of the page where you can add the promo code. If your account is older than 30 days, you can go ahead and contact us at sales@rescale.com and we'll apply that credit manually. I also want to invite everyone back to our next webinar, which will be held at the same time on April 18th. Okay, now on to Q&A. I'll kick things off with a question or two. Fanny, can you tell us How are ANSYS licenses managed on Rescale?
Yeah, sure. You have different type of license, and your license can be either hosted on the Rescale platform, or it can be also hosted on your on-premise. So the way we connect to your premise environment is going to be either through a VPN or through a SSH tunnel. If we host the license and need to check them out on your local premise, you can also leverage the same technology, so a VPN or SSH tunnel, to be able to access the license server that's on Rescale to running like on-premise application.
Okay, and is ANSYS 18 already available on Rescale?
It is, yeah. We made it available recently, so it's both available, the different solvers technologies available on R18, and you can also leverage the pre and post-processing UI, R18 UI that's available on Rescale desktop.
Great. Okay, we have a question from Matt. Do we need to have front-end software for software design stage, or can that too be done on the cloud?
So for typically the process going to be any design work is going to be done locally on your machine. And then you can import your CAD model into Rescale and spin up a remote desktop session to be able to do the pre-processing, mesh your model, apply load and boundary condition, and then as Raul demo, you can submit this job from Workbench to Rescale directly, and then post-process everything into the remote desktop again to look at your results. So you, except for the CAD part, you're able to do everything on Rescale. You just need to import that CAD part as a job, as an input of your job, and sync that with the remote desktop session.
Okay, and can you tell us what the difference is between a core and a slot?
So, do you want to reply? Okay, so slot is really allowing you to run more jobs concurrently. It's just kind of a different terminology that we used to specifically say that this is the number of concurrent tasks, while a core is essentially like a CPU that you want to leverage as part of your job.
The cores and slots are only applicable to the DOE framework on Rescale. So let's say you choose 4 cores and 4 slots. What that basically means is that you can have 4 concurrent tasks running at the same time, each of them using 4 cores to compute. So just now we had 16 runs, so if we used 16 slots and 4 cores, we could run every single run concurrently using 4 cores.
Okay. Is it possible to select various high-performance parallel file systems?
I'm going to need to follow up on that.
Okay. Okay, we'll follow up on that question after the webinar. Yeah. Okay. Well, I don't see any more questions coming in, so if there are no further questions, I think we will call it a day. So thank you all for attending. Just once again, I'll be sending out a follow-up email including the promo code and the recording later this week, and it will also be, the recording will also be in the March newsletter. Okay, bye and thank you.
Thank you, everyone.